introduce David Haynes, who's a colleague at the University of Minnesota. David is an assistant professor at the Institute for Health Informatics at the U of M's Medical School. He's also on our MGIS graduate faculty. He teaches a wonderful course on spatial database design and administration. Also has taught GIS programming for us in the past, and really is a valued member of our faculty. In addition to that, he's co-director of the Minnesota Population Center's Diversity Fellowship Program, which is a wonderful program that some of our students have been able to participate in. So we thank him for all his great roles at the university. He also really has some very timely and I think interesting interest areas, which include GIS and big data, spatial analysis and high performance computing, and does some really interesting applied work in health and population geography. So I'm going to hand it off to David. Looking forward to it.
Hi, Susanna. Thanks so much for the nice introduction. So I'm going to talk to you guys today, I guess, a bit about some of the future directions and trends that I participate in with GIS, and kind of building off some of the last bit of the speakers. I just kind of want to, I tried to provide some ideas about the tools and the skills that I've used in some of these sort of projects to kind of help you understand what will be useful for your career development, and sort of some sorts of skills that you might want to build in to kind of be able to apply GIS in different ways. And so I dabble a little bit in computer science, a little bit in health, but I'm mostly a geographer. And so this is kind of the work that I do. Next slide. So I hope today, when I'm done with this, you'll be able to walk away with knowing a little bit of things. Hopefully you'll be able to understand what is big spatial data, how you can apply it to your career. And my expertise is really in health geography. So I want to let you know about a few things about John Snow. There's a lot of stuff going on right now with health geography right now with coronavirus. And so there's some things that we'll talk about there. But really how GIS, particularly for health, now could be answered, is really being used and being thought about a lot to answer new sorts of health questions, and how GIS can really be applied to answer those sorts of things. Okay, next slide. All right, so big spatial data. This is a term, well, big data is a term that you may or may not be familiar with, but this is a new term that's been coming out of computer science for the last almost 10 years now, relating to the new sorts of data that's coming out and how to kind of handle it. And this is now becoming something that's really apparent with spatial data. And there's three characteristics of this that you should just kind of be aware of. Spatial data just generally has always been big. We've always been using databases and other sorts of tools to really look at our data. If you think about the shapefile itself, the individual shapefile has a little DBF file, which is actually a very basic old school database. And so spatial data has always been kind of big, but now it's getting even bigger. If you think about all of the sorts of automated cars that are going to be driving around, everyone using their cell phones to find locations, there's all this new sort of sensor data that's coming out. And so the volume of it's growing, but not just the volume, the total amount, how fast it's coming out. If you think about all the requests that are coming from the internets and from the phones, there's just a lot of different questions that are being asked. And so the ability to process and use that data is really changing. And that's something that's really new to GIS folks. If you could imagine, if you had a shapefile, or if you're looking at some satellite imagery, and that data started to update, every day, and then it updated every week, every hour, and it just kind of kept increasing the amount that it was updated, you would not want to be going through a kind of a command or a regular sort of desktop GIS process to keep handling all of these new changes with the data. You would really want to develop something that would be able to be automated to kind of handle all these sorts of changes. And so that's really pushing us to think about GIS data and how we handle it and how we're going to process this stuff really differently. And then there's this variety, which is kind of new, but GIS really has two real big divides that we deal with a lot. Some people may come more or less from the remote sensing and sort of satellite imagery side and very familiar with the tools that are developed around that. And other people may come from more of the shapefile and geometry sort of side. And that creates real interesting, complex ideas when we're thinking about big data that's always changing and coming from different sources. And so go ahead and go to the next slide. I spent about a year trying to, because I was working on a scientific project, and we were trying to see if we could do some really cool analysis at scale. And I went around and I searched for a year to see if I could find a single system that actually did big data for vector and raster and did it at scale. And we haven't built it yet. And it's not been built yet today. And I don't know if anyone's focusing on building it now, but it'd be great if you've built that. You can let me know in the chat and I can use it. That would be very helpful. But you can see that we really don't. A lot of people really focus on developing on one side or the other. Most of us either focus on vector or raster. But the idea of how those two systems will intermix and work together hasn't really been addressed. And especially for big spatial data, the scalability of those processes is really kind of in its beginning stages. And so some of my work really kind of focuses on, well, how are we going to be able to use these sorts of expertise that we all have and scale these sorts of analyses out. Okay, next slide. And so one of the things that I did, and one of the things I try to put some stickers here so that people can understand, but looking at some of the tools that are out there, and I teach a spatial database course. And so I'm very familiar with a database called PostgreSQL, but there are also lots of other systems that are out there. And spatial data just in general is being thought of very differently by engineers and other folks, and they're bringing it into new systems. And I really wanted to see, well, how do these new systems think about spatial data and how will they work? And so PostgreSQL is a database. It has an extension called PostGIS, which will allow it to work with spatial data. I think in the presentation before this, they were talking about SQL becoming much more important for spatial data. And I would agree very strongly that we're finding out that you can do almost all the spatial analyses that you need to do within a database system like PostgreSQL and PostGIS. And so I was testing that system out to see how it would work on big spatial data. There are two other systems which are coming from the big data community. One is this database called SiteEB. This really just looks like at volumes of satellite imagery. And this is just going to look at satellite imagery. I'm going to do some analyses on this. And it just will load multi-dimensional arrays, and it treats them as, it treats the satellite data as just a big array, and you can process it and query it. And then the last platform I was looking at was called GeoTrellis, and this comes from Spark. Have you heard of that? There's a new framework out there that comes from Hadoop, which does a lot of computation and memory. And this was looking at this. And so I wanted to see how these platforms would look like at big spatial data. Go ahead and go to the next slide. So we needed to get some big computers to do this work. So we ended up getting some nodes from an organization called Exceed. And this is just kind of a part of a scientific research program. But we had some big computers that had lots of RAM, 128 gigabytes of RAM, and we ended up needing all of it. Go ahead and go to the next. And so what I was going to do in my research was I just really wanted to see how would these basic operations you can think about that you guys do already in desktop GIS software, or maybe you've programmed them, how would they fit or how would they perform on these big platforms? Go ahead and go to the next slide. So I'm going to take a look at just the continental US. And I have 3 different data sets that I'm going to look at just for the continental US. One data set here only has 18 million pixels. And we're working with big data, so 18 million pixels now becomes very small. And we're going all the way up to 1.69 billion pixels. And I'm going to look at how you do any of these operations on these data sets. Go ahead and go to the next slide. And so this is just counting the entire data set, counting all the pixels that are there. So I told it, find me pixel value 2 for the whole data set. And this is how fast these systems go. You'll see that SciDB doesn't even take 1 second for it to cover 16 million pixels. It counted all of them. It's very, very fast. And Postgres was doing this in 3 seconds. So each of them have the ability to do a lot of the basic sort of raster calculations very, very fastly. And this really allows us to then start thinking about what sorts of analyses that take a long period of time can you start doing on these systems, right? In a much quicker fashion. One other thing that kind of point out with this is you'll notice is at the bottom there, I'm showing this thing called tile sizes. So if you're familiar with satellite imagery, you know that we download, because the data is usually so big, we download it in tiles. Well, each of these systems, again, kind of loads the data in these sort of tile formats. And so one of the things that's really important to know is that depending on the tile size, it's going to change the performance. So you can see that if you load the data, if you're looking at the dark blue with GeoTrellis, you can go you can get almost at 1 second, up to 3 seconds, depending on how you loaded it. And so this is really important because a lot of spatial researchers are not familiar with a lot of these technical details. And so when we start using these big data platforms, we make some naive mistakes. And so we end up slowing down the performance of a lot of our analyses because we're not really sure how to use them. Go ahead and go to the next slide. And so this sort of thing comes out when you look at the big data sets, it becomes really apparent. So when you go all the way down to the national land cover data set, this is for the whole US, the whole continental US, it takes SciDB 14 seconds to cover the entire US. It can do a calculation across that data set in 14 seconds. And so for people that are looking to have lots and lots of data, so for instance, there's a lot of climate model data that comes out in a raster format, right? And there's just petabytes of it. You need every single second. And so these sort of systems can now start to analyze and look at these data sets because they're able to analyze the entire data set so quickly. And so you get about up to 5 times speed up by using a system like SciDB or GeoTrellis. They really, really speed up and go a lot faster with the data set. All right, go ahead and go to the next slide. So this is where the computer science kind of comes into understanding how it kind of relates to geography. Understanding how the data is being used by geospatial researchers is really important. And most times I work with a lot of computer scientists that are not really kind of aware of how the data is going to be used. And so it's very useful to have an understanding of how data is downloaded and structured and how to load it into the system so that you can actually get the analysis done correctly and at scale. And so this little picture just shows how, in a way, I would have to divide up the data to get it to load into the system. And there might be some benefits if you think that you're working only in the continental US about how to make this more efficient. And so overall, I think there's a real big trend within a lot of GI science, the community, to understand a bit more about computation and how this will really affect our ability to analyze our data, because we have so much data and it's becoming very, very cumbersome to kind of do this all on your computer. So you need to really start working on this stuff in the cloud and big computation environments. Next slide. And so now I'm going to switch to kind of my bread and butter, which is health geography, and just give you an overview of some of the topics and tools that I've been kind of working with there. So health geography is a discipline that's been around for a long time. And this picture here is requirement for anyone that's a health geographer. You put in a picture of John Snow and the Broad Street Pump. And then I'll just give you a little bit of a background. So health geography is kind of born out of this example. So I don't remember exactly when right now, but there was a cholera outbreak in England. And a researcher by the name of John Snow was going around and trying to figure out where the cholera outbreak was located. And so what he was actually doing was he was going down each of these roads, and this is a map of the town, and he was trying to figure out where the people were that were sick. And by putting them on a map, he kind of deduced that the Broad Street Pump was potentially the source of this outbreak, right? By putting it on the map and showing the location of where these individuals were, he was basically saying, this is where I think the is. And so he took the handle off the pump and saved the town, and everyone was happy. And this is kind of one of the main outgrowths of health geography, which is we need to map what's happening, right? Tables are not good enough to understand where epidemics are occurring. We need to, oh, thanks, Andy. We need to actually know where the outbreak is occurring. And so from here, what we've really seen, and you'll see this always with all the maps now for COVID, is that there's all these choropleth maps kind of identifying the areas of where individuals are. And you can really start to apply very basic to very sophisticated GIS tools to really understanding lots of information about health. And health is really broadly starting to understand the need for answering the questions spatially. And so this is an area that's still growing. It's been growing for the last 10 years. And there's really a need for people to be able to answer these sorts of questions for lots of health practitioners and people that are trying to make decisions on health. And so this can be all the way from something serious like COVID or disease outbreaks or hazardous waste to things just like food deserts and understanding how far all of these things are. There are lots of implications across government that have to do with understanding the distance and the relationship between people and some sort of service. And so there are lots of ways that you can apply GIS skills broadly within health. Okay, go ahead and go to the next slide. So I'm actually working with the Department of Health right now on a breast cancer screening program called SAGE. And the problem that they kind of brought to me was that they had, they were not really sure. They have a number of women that get screened. Let's say it's about 10,000. And they had seen those numbers go down. But if they have 10,000 women that they screen every year, were they reaching all the communities that they were supposed to be reaching? Again, this is something that can only be answered in a lot of ways with a map, because 10,000 people could be spread, this is a statewide program, it could be spread across the state very differently. And so they really wanted to know if they were really reaching all the communities that they thought they were supposed to be meeting and how to go about doing that. And so what I ended up doing was I used some really kind of sophisticated techniques to help show them that information. Go ahead and next slide. So this is a mapping technique that I learned in graduate school, and I just want to kind of show you how it kind of compares to a general technique. But so this is just a choropleth map here on the right, showing some of the numbers that they were kind of able to calculate with my help, showing how many people they were actually reaching. And so you can see where they're doing really well in the green and where they're not doing as well in the dark brown. And then I was able to use a more sophisticated technique to really highlight and show the gradients, the transition points between this. So choropleth maps have some issues with not being able to show the gradients. And I was able to convert this map over into a spatially adaptive filter map on the left. And you can really see these highlighted, very concentrated areas. And the state doesn't look as overall as good as you see with the county utilization map. But this was really helpful for them to really understand just in a lot of ways who they're reaching and who they're not reaching, and really think about this because they have providers in all these areas and they really wanted to make sure they're reaching all these communities. Go ahead and go to the next slide. And so here you can see here with the zoomed in map, we can go all the way to these neighborhoods. And so now this is in the Minneapolis-St. Paul area, and these are the neighborhoods here. And so now you can really see exactly where they were reaching people. And so the pixels on this are really, really small. They're about 500 meters square pixels. And so now we get a real good understanding of what communities we're missing and which ones we need to do a lot better in. And this has been very helpful for them because now we're able to take dollars and really allocate them to the right communities to make sure that we're getting screening up, because this is a very, cancer screening is really important these days. Go ahead and go to the next slide. Now I'll go to the big elephant in the room, COVID. As Susanna was saying, I teach the Master's GIS program, and COVID happened during the spring. And so we were kind of trying to figure out, as COVID was happening, and my students have a project at the end of what to do. And I suggested to them that this was a really interesting opportunity to think about in our database course, right? We're getting all this data. It comes to us every day. And it's hard to analyze this and look at it without a more sophisticated system like a database that can really catalog all this information. And so I suggested that we create a web map. And so each of the students, we had a lot of fun learning some of the tools that we had to use to do this, but we were able to use some open source tools to create a really interesting web map. And overall, we've kind of taken it a different way. And so this is a web map that actually looks at some of the existing COVID data that's out here publicly for the New York Times is collecting this one. This is not using the Johns Hopkins API. But then what it does is it does a cluster analysis on this, and that makes these areas of interest. So you can actually see where you're getting clusters of cases of disease. And so we think that this is a really useful tool for understanding what's happening, not just on a day-by-day basis, what's happening over time. And so we have the ability to animate it. You can zoom in and pan, and you can change a lot of things within the map. And I think this is a really interesting sort of application of what you can really learn and do with spatial data. Go ahead and go to the next slide. So I'll just kind of briefly kind of go over some of the front end. When we first started developing this, we were all pretty new to GIS web mapping. Again, I really spent a lot of my time doing a lot of the back end sort of stuff. And so we started with a leaflet sort of idea of making the web map using a lot of JavaScript and things like that. The end resulting is a little bit more developed. We are using two frameworks, React and Redux, to actually do and control the state of this sort of thing. And this allows us to do some really interesting things. So in the map now, you can change the colors, you can change the classifications. There's lots of different variables you can play with. And so this allows people to really understand what's going on within the data itself, to actually see and understand how the data is changing on a day-to-day basis. But the backend is really important to understand. Here we're using GeoServer, which is analogous to ArcServer. This is just an open source tool that we ended up using. And we're also using PostgreSQL again and PostGIS to display the data. And so here we're actually taking all the data that comes in every day, we're doing some sort of transformations on it, and then displaying it back out for people to use. Next slide. And so the map has a lot of functionality. I suggest that you check it out. I think that they've sent some links, but we have some really cool capabilities in here that the students help prepare. At the time when we started this, COVID wasn't as rampant as it is right now. And so, we had to really think about what did people want to see and understand. And so the state and county were two things that people were really interested in. Right at the time when this project started, there was a lot of interest in understanding what was happening in New York In most of the country, except for, Washington and Seattle, there wasn't as many cases. And so people sometimes wanted to see the data at the state or the county. We also put this kind of a calendar icon thing where you could change the date. And you can actually animate it if you want. So you can actually see the map change over time if you want to see there. So the whole data time series is there. And you can actually see that. And then the students really picked out the data sets that they wanted to change, because there was a lot of stuff, and you'll still see a lot of maps that talk about the cumulative cases. And so we really wanted to change this to daily cases. So what's happening, what's the change day by day? So we have some things that tell you that. We do clusters on all these sorts of things, and it's all here. We actually did try to do some work initially with trying to see bed capacity, but our algorithm didn't work as well as we wanted, so we had to drop that sort of case. But there's a lot of interactivity here, and this is a really good idea of how something that's very GIS really needed some computer science expertise and web mapping to really make this idea of what's really available and happening there. And so this is really being used by health officials to understand what's happening across the nation. And it's being used to kind of understand what clusters and things like that are really occurring. Next slide. So here's just a couple of images here. So again, you don't have to just look at clusters. So this is looking at cumulative cases, and you can change the breaks and things like that. We've done some things where you can really play with this. And so GIS is really moving in a lot of ways to where the fact where a lot of the tools and capabilities that you need on a desktop GIS can really be moved into a web mapping framework where you can really see what's happening. And so this is just a really cool example of being able to make a map really interactive and exploratory for anyone to be able to use. You don't have to have a GIS background to use this map. You just have to be able to choose the sort of things that you want to do. But it does take a lot of GIS expertise to be able to understand all these sorts of things, like understanding what breakpoints mean and all those sorts of data that we kind of think about is really kind of important for creating a map. Translating that over is very difficult and takes a lot of different expertise. Next map. So this is just the end kind of part here about this. So the end result of this is we have a lot of cool things happening in the background. We do these things called spatial clusters. This is a spatial statistical technique that tells you where hot spots and cold spots are. And we ended up using a lot of different tools to do this. Again, I do a lot of dabbling with computer science, so we're using Python and GitHub and PostGIS to kind of work together. And this just allows us to really do this sort of analysis. And we're really trying to make sure that this is open and approachable for lots of different researchers that want to understand what's happening in their area. Next slide. And so, yeah, I think that's it. Please. Oh, go ahead and go to the next. Yeah. Oh, more slides. Okay. Oh, there's the animation. Okay, good. So yeah, so this is just showing you an animation of what's happening there in the website. This is just some data that really allows people to really see what's going on there. And we're trying to work with health officials to really understand what do these clusters mean in terms of movement and things like that. Thank you. If you have any questions, I can answer them now.
So I didn't see any questions come up in the chat, but there were some questions earlier today that I think are very relevant to this. And I think before the current pandemic, there weren't a lot of people going into GIS intending on focusing on health. So there's probably a lot of people out there majoring in other things with experience in other things. And one of the questions that came up is how important is it to have a specific degree for a specific application like this, or specific experience? So maybe you can talk about that. Careers in health using data analytics, if you never majored in data analytics or health, but have GIS.
Yeah, so I would say that it's not as important as it used to be. There used to be a strong feeling that you needed to have a master's in public health to be able to answer these questions. But I think that now there's a bigger realization that people have very specific expertise and can answer those questions. So if you are an expert in geography and you can really tell people how the map and how the data needs to be constructed and answer those questions, you can partner with someone that has the expertise in health. And that's kind of what I do. I don't try to be an expert in all things related towards cancer or any sort of health disparity. I take a look at that question and I say, well, this is a geographic problem. What do we know about the population and those sorts of things there that would make this disease potentially be higher here, and try to approach it from that angle. So I think the more that you can have an expertise in geography, you'll be able to be a part of a team that can answer those questions. So does that, I think that's kind of where I'm thinking now, is that there's more people that are going into, I'm a GIS expert, I can help answer health questions, versus I'm a health expert that wants to do GIS and I don't have a lot of expertise in how to do the geographic part.
Yeah, thank you. That's perfectly in line with some earlier discussion too about being able to tell your story and how you've applied the technology for critical thinking processes is more important than being able to demonstrate I used it for that exact same purpose, because it's definitely applies across the board. Were there any other questions for Dr. Haynes? You can put them in the chat or unmute and ask if you like. As we mentioned before, Dr. Haynes and all of our presenters have their email addresses on the main agenda page, so you can go there and follow up with them later if you would like.